October the 12th, 1940, 05:45 hours, somewhere beneath Corsham, Wiltshire. Thomas Garrett descended the staircase for the fourth time that week, his miner's lamp casting shadows on limestone walls that had stood undisturbed for millions of years until 6 months ago. The stairs went down 120 feet through rock that Rome's legions had marched over, that Saxon farmers had ploughed above, that nothing human had touched below until 1940 brought war and desperation in equal measure. At the bottom, the staircase opened into a cavern that geology had created and industry had claimed. The space stretched 400 yards in one direction, disappeared into darkness in the other, cathedral-scale chambers that echoed with sounds no cathedral would ever contain. The shriek of metal lathes turning aircraft engine components, the rhythmic hammer of presses forming steel sheets, the hum of generators powering lights that turned eternal darkness into something approximating day. Hundreds of workers moving between machines, operating equipment that had been dismantled in factories above ground and reassembled here beneath 100 feet of protective stone. Thomas made his way to his station in Section C, where he supervised production of Bristol Hercules engine cylinders. 3 months earlier, his section had been in a factory in Filton, exposed to sky where German bombers had destroyed neighbouring buildings and killed 17 workers in a single raid. Now they worked beneath earth where bombs couldn't reach, where Luftwaffe reconnaissance couldn't photograph, where Britain's war production continued regardless of what happened to the world above. He checked the night shift's production logs, pulled on work gloves that would be grey with limestone dust by shift's end, and began another day in a factory that officially didn't exist, manufacturing engines for aircraft that Britain desperately needed, working beneath ground because working above it had become impossible. The arithmetic of vulnerability, Britain in autumn 1940 faced industrial mathematics that offered no good options. German bombing, which had begun tentatively in summer, had intensified through September into sustained campaign targeting Britain's industrial cities. The Luftwaffe wasn't just trying to destroy RAF airfields or break civilian morale. They were systematically attacking Britain's capacity to make weapons, to produce aircraft, to manufacture ammunition and equipment that sustained the war effort. The numbers were stark and getting worse. Between September 7th and November 13th, 1940, German bombers struck British cities every night with only 5 exceptions. They hit Birmingham's industrial quarter repeatedly, damaging factories that produced everything from aircraft components to artillery shells. They bombed Coventry so thoroughly on November 14th that the city's industrial centre effectively ceased to exist, with 12 aircraft factories destroyed or severely damaged in a single night. They struck Bristol, Sheffield, Manchester, Liverpool, anywhere that produced military equipment or hosted war industries. British industry responded initially by attempting to disperse production, spreading manufacturing across more locations so that no single raid could cripple output. But dispersal required factory buildings, and factory buildings were visible from air, identifiable as industrial targets vulnerable to bombing regardless of location. A factory in Birmingham could be bombed. Moving production to Manchester just meant Germans would bomb Manchester. Dispersal didn't solve the fundamental problem that factories needed roofs and roofs could be destroyed. The casualties compounded the crisis. Workers killed in raids couldn't be replaced easily. Skilled machinists required years of training. Workers who survived bombing but lost homes became refugees needing housing before they could return to work. Workers who watched friends die in factories became reluctant to show up for shifts when sirens sounded nightly. Absenteeism from fear was as destructive to production as bombs themselves. Traditional solutions wouldn't suffice. Building bomb-proof factories above ground was impossible. Reinforced concrete thick enough to withstand direct hits from 500-pound bombs would require years to construct, and material Britain didn't have. Continuing production in existing factories meant accepting casualties and production interruptions that Britain couldn't afford. Moving factories to rural areas away from cities just meant Germans would eventually identify and bomb new locations. The solution emerged from multiple sources almost simultaneously, engineers and planners reaching similar conclusions through parallel logic. If surface factories were vulnerable and building bomb-proof structures was impossible, then perhaps Britain should stop building structures at all. Instead, they should use structures that already existed, that nature had built, that were inherently protected by characteristics no engineer could replicate. Britain should move its factories underground. The geologist's opportunity, Britain possessed underground spaces on scale that seemed designed for industrial repurposing, though they'd been created for entirely different reasons. Centuries of mining had honeycombed areas of Wales, northern England and Midlands with tunnels and chambers. Limestone quarrying around Corsham, Bath and Chilmark had created vast subterranean voids where stone had been extracted for construction. Natural cave systems in Derbyshire and elsewhere offered spaces that had existed since before humans. Railway tunnels that had become redundant or could be repurposed provided ready-made protected routes and spaces. The potential had been recognized before war began. In 1938, planners surveying British industrial vulnerability had identified underground locations as potential sites for protected storage of equipment and supplies. But moving active production underground seemed impractical, expensive, technically challenging in ways that peacetime resource allocation couldn't justify. Bombing changed calculations completely. What had seemed impractically expensive in 1938 became urgently necessary by 1940. What had appeared technically challenging became worth attempting when alternative was accepting factory destruction. The government established Underground Factory Committee in October 1940, tasked with identifying suitable locations, coordinating relocations, solving technical problems that underground production presented. The committee's criteria were specific. Spaces needed to be large enough for industrial equipment, with ceiling heights permitting overhead cranes and floor space accommodating assembly lines. They needed to be accessible by road for transporting materials in and finished products out. They needed geological stability, rock that wouldn't collapse under vibration from machinery. They needed ventilation potential, ways to supply fresh air and exhaust fumes and heat that machinery generated. They needed to be near existing industrial centres so that relocating factories didn't mean relocating entire workforces. Survey teams fanned across Britain, examining abandoned mines, old quarries, railway tunnels, natural caves. They consulted geological surveys, interviewed miners familiar with underground spaces, studied Victorian engineering plans for tunnels that had been built decades earlier for different purposes. They identified hundreds of potential sites, then narrowed list through practical assessment of what could actually be converted to industrial use within timeframes that mattered. By early 1941, sites had been selected for initial conversions. Corsham's limestone quarries would house aircraft engine production. Drakelow, near Kidderminster, would become underground rover factory producing aircraft engines. Spring Quarry, near Swindon, would manufacture aircraft components. Harpur Hill, near Buxton, would house munitions storage and production. Rhydymwyn in Wales would produce chemical weapons if needed, conventional munitions otherwise. Dozens of smaller sites would handle component production, storage, assembly work. The engineering challenge was enormous. These weren't empty spaces waiting for equipment. They were raw caverns, rough tunnels, spaces that had been excavated for stone and then abandoned. Converting them to factories required installing power supplies, lighting systems, ventilation equipment, water sources, drainage, transport systems to move materials, foundations for heavy machinery, partitions to separate different production areas, offices for management, facilities for workers. It required doing all this while bombing continued above ground and while the factories being relocated needed to maintain production somehow during transition. But Britain had run out of alternatives, so engineering challenges would be solved because they had to be. From caverns to production floors, the conversion of Spring Quarry near Swindon illustrated both the scale of effort and the ingenuity required. The quarry consisted of interconnected chambers where bathstone had been extracted since Roman times, creating spaces ranging from basketball court size to areas that could fit football pitches. The ceiling height varied from barely 8 feet in some passages to over 30 feet in main chambers. Temperature remained constant year-round at roughly 50 degrees Fahrenheit. Humidity was high. The floor was uneven rock. There was no lighting, no power, no ventilation beyond what occurred naturally through old quarry entrances. Initial surveying teams in December 1940 mapped the usable space, identifying chambers suitable for different purposes. Larger chambers would house major production equipment. Smaller spaces could serve as storage, offices, or workshops. Passages would become transport routes connecting different production areas. The mapping took weeks, engineers working by lamplight to measure dimensions, assess structural stability, identify where modifications were needed. Simultaneously, engineers above ground were dismantling equipment from Supermarine's Southampton works, which had been bombed repeatedly and was no longer safe for production. The machinery was massive, some pieces weighing tons, precision equipment that had been installed in Southampton factory with cranes and special foundations. It all needed to be disassembled carefully, transported to Wiltshire, lowered down quarry shafts, or carried through entrances too narrow for some equipment and reassembled underground. The logistics were nightmare. Machine tools couldn't simply be unplugged and moved. They required careful disassembly, preserving precise alignment and calibration. Transport lorries had to navigate wartime conditions with blackout restrictions and fuel rationing. At Spring Quarry, equipment had to be lowered by crane and winch into the quarry or brought through entrance passages that required widening. Inside, the rough floor meant equipment couldn't simply be placed and leveled. Foundations had to be built, concrete poured on rock, mounting points established that would keep precision machinery stable despite underground environment. Electrical infrastructure required particular ingenuity. Surface factories connected to national grids straightforwardly. Underground factories needed power brought in through cables, then distributed through chambers and passages without normal wall structures for mounting wiring. Engineers improvised, running cables through passages carved specifically for infrastructure, installing substations inside chambers, creating power distribution systems that could supply hundreds of machines operating simultaneously. Ventilation presented challenges that intensified as production began. Machinery generated heat. Hundreds of workers generated heat and consumed oxygen. Metalworking. Processes produced fumes that were hazardous in confined spaces. Natural ventilation through old quarry entrances was insufficient. Engineers installed industrial fans, ducting systems that drew fresh air from surface and exhausted stale air, heating systems for winter months when workers needed warmth that 50-degree ambient temperature didn't provide. The ventilation systems consumed enormous power themselves, adding to electrical infrastructure requirements. Lighting transformed spaces that had been dark for centuries. Engineers installed overhead lighting throughout production areas, trying to approximate daylight conditions that would help workers maintain normal circadian rhythms despite being underground. The lighting was never quite adequate, creating shadowier environment than surface factories offered, but it sufficed for work that required precision. By March 1941, 3 months after conversion began, Spring Quarry was producing Spitfire fuselage components, output gradually increasing as workers adapted to underground conditions. and equipment was fine-tuned to cope with humidity and temperature different from surface factory conditions. Similar transformations were occurring at sites across Britain, ancient spaces repurposed for modern war, geology providing protection that engineering couldn't replicate. The workers' underground existence. Dorothy Mitchell had worked at Vickers Supermarine in Southampton since 1938, operating a press that formed aluminum sheets into aircraft components. When the factory was bombed in September 1940, she'd been home on shift break. 3 friends working her normal shift died in the raid. When Vickers offered her position in new underground facility at Corsham, she accepted immediately. Working underground felt safer than working under open sky, where bombs fell randomly. The descent each morning took 15 minutes downstairs that seemed to continue forever, passing markers that noted depth. 50 feet, 75 feet, 100 feet, finally arriving at production floor that existed deeper than many coal mines. The temperature was constant, neither hot nor cold, but perpetually cool in ways that soaked through clothes and made warm jackets necessary even in summer months above ground. The air smelled of limestone dust, machine oil, and the peculiar dampness of spaces where moisture had nowhere to evaporate to. Work itself was familiar. The machinery was same equipment she'd operated in Southampton, disassembled and reassembled underground, but functionally identical. The aluminum sheets still required same pressures, same dies, same technique to form properly. But the environment was profoundly different. The ceiling curved overhead, rough stone visible beyond overhead lights. The sounds of machinery echoed strangely in limestone chambers, creating acoustic environment that took weeks to adjust to. Conversation required shouting even when standing close, because echoes confused directionality of sound. Time became abstract concept underground. Day and night were indistinguishable. Dorothy's shift might begin in darkness and end in darkness, or begin in daylight and end in daylight, but underground those differences were invisible. The factory operated on clock time, divorced from natural cycles, shifts rotating through hours defined by production schedules rather than sun position. Workers wore watches religiously because without them time disappeared into continuous present of artificial lighting and constant temperature. The psychological impact varied among workers. Some found underground environment comforting, feeling protected by rock overhead, immune to bombing that made surface life terrifying. Others found it oppressive, the enclosed space triggering claustrophobia that made work challenging. The constant dampness wore on everyone, creating feeling of never being quite dry, clothes that felt perpetually slightly moist, respiratory issues that developed in workers who'd never had breathing problems in surface factories. Social dynamics of underground factory differed from surface equivalents. Workers couldn't step outside for breaks, couldn't see weather, couldn't gauge time by sun position. Breaks occurred in designated areas carved from side chambers, spaces where workers gathered to eat meals brought from surface or provided by canteen that operated in converted quarry chamber. The isolation created intense sense of community. Workers depended on each other more than in surface factories where one could leave at shift end and disconnect. Underground, everyone was literally in the same situation, couldn't escape except by ascending together. Health concerns were legitimate and mostly unaddressed. The limestone dust that permeated everything caused respiratory irritation. The humidity exacerbated joint problems and made some workers susceptible to fungal infections. The constant exposure to artificial light disrupted sleep patterns. The Ministry of Labour monitored conditions but had limited ability to improve them significantly. Underground work was inherently less healthy than surface work, but it was safer from bombing, and that trade-off seemed acceptable when German aircraft attacked nightly. Women constituted substantial portion of underground workforce, employed in roles that pre-war assumptions had insisted required men. They operated the same heavy machinery, performed the same precision work, endured the same underground conditions. Some male workers initially resented female colleagues, expressing skepticism about women's capability for industrial work. The skepticism faded as women proved equally capable, learning machinery operation quickly, maintaining production pace, tolerating underground environment as well as or better than male workers. The constant production pressure was intense. Britain needed aircraft desperately. Every component produced underground was component that kept RAF flying, kept defending Britain, potentially prevented invasion. Workers understood this viscerally. Production targets were ambitious, constantly pushing for higher output, more components, faster turnaround. The pressure created stress that underground environment intensified, but it also created purpose. Workers knew their labour mattered, knew they were contributing directly to national survival. The hidden logistics production underground required support systems that surface factories took for granted. Material had to be transported from suppliers to underground facilities, often travelling circuitous routes because direct roads didn't exist to quarry entrances. Raw aluminum, steel, other materials arrived by lorry, was unloaded at surface, then transported down into production areas by rail systems installed specifically for underground logistics or by lifts that descended through shafts. The rail systems were engineering achievements themselves. Spring Quarry installed narrow-gauge railway running through main passages, connecting different production chambers to lifts that brought materials from surface and removed finished components. Workers operated small locomotives that pulled wagons loaded with materials, navigating tracks that curved around geological features and threaded through passages that had been widened just enough to permit rail passage. The railway was essential because manually carrying materials through passages was impossibly inefficient. Finished components had to exit the underground facilities to reach assembly plants where aircraft were completed. This reverse logistics required same transport systems, components carefully packed to survive handling and transport, loaded onto rail wagons or lifts, brought to surface, loaded onto lorries that delivered to final assembly facilities. The chain had to remain continuous because interruption meant production piling up underground with nowhere to go, halting manufacturing while waiting for transport capacity. Quality control presented unique challenges underground. Aircraft components required precision measurement and inspection. Temperature and humidity affected measurements subtly but significantly. Gauges and measuring instruments had to be calibrated, accounting for underground conditions that differed from surface standards. Inspectors developed expertise in compensating for environmental factors, learning how measurements taken at 50 degrees and high humidity translated to specifications designed for standard workshop conditions. The security surrounding underground facilities was comprehensive. Locations were classified, appearing on no public maps. Workers were instructed not to discuss their work or even acknowledge underground facilities' existence. Guards monitored entrances, checking identification of everyone entering or leaving. The secrecy was partly to prevent German intelligence from identifying facilities' locations, but also to prevent sabotage. A single determined saboteur could damage underground production more severely than surface bombing, because concentrated facilities meant one successful attack could affect multiple production lines. Communications between underground facilities and government ministries required secure systems. Telephone lines ran from surface to underground offices, conversations conducted carefully to avoid revealing classified information. Messengers travelled between facilities carrying written orders and production reports. The administrative coordination required to keep multiple underground facilities operating in synchronization with surface assembly plants and military requirements was enormous, managed by civil servants who navigated complexities without computers or modern coordination tools. The life that emerged by mid-1941, underground facilities had developed characteristics approaching normalcy despite extraordinary circumstances. Workers established routines, learned to navigate underground spaces confidently, adapted to environmental conditions. The factories functioned with increasing efficiency as teething problems were resolved, and workers gained experience with underground production. Some facilities developed extensive amenities, attempting to make underground existence more bearable. Corsham installation included canteens serving hot meals, medical facility staffed by nurses who treated injuries and monitored workers' health, recreation area where workers could relax during breaks. The recreation area was surreal, underground chamber carved from limestone outfitted with chairs and tables, posters on walls, radio playing BBC broadcasts, creating approximation of normal break room in entirely abnormal setting. Managers experimented with shift patterns trying to optimize productivity while minimizing worker fatigue. 8-hour shifts proved difficult underground, where environmental factors created exhaustion more quickly than surface work. Some facilities tried 6-hour shifts with more frequent rotation, finding this improved productivity despite reducing individual worker hours. Others maintained 8-hour patterns but instituted mandatory breaks, forcing workers to rest even when production pressure encouraged working continuously. The relationship between underground facilities and surface communities was complex. Towns near underground installations benefited economically from sudden influx of war work and workers, businesses thriving from increased custom. But locals were instructed not to discuss what occurred beneath their fields and villages, creating strange cognitive dissonance of knowing something important happened underground while pretending ignorance. Workers who'd relocated from bombed cities to live near underground facilities experienced cultural dislocation beyond just underground work. A Manchester woman working in Welsh underground facility wasn't just adapting to underground environment, but to rural life vastly different from urban upbringing. A Londoner working in Wiltshire Quarry was learning to navigate countryside, while simultaneously learning to navigate limestone tunnels. The geographic displacement compounded psychological challenge of underground work. Children of workers who'd relocated often had no idea what parents actually did. They knew their mothers or fathers went underground daily, but the specifics were classified. Children created imaginative explanations, elaborate fantasies about what occurred beneath ground. Some weren't far from truth, others were wildly inaccurate. Parents couldn't correct misunderstandings without violating security requirements, creating family dynamics where a significant portion of daily life was undiscussable. The underground facilities created their own folklore and culture. Workers developed superstitions about particular chambers being lucky or unlucky, about rituals that supposedly improved production or prevented accidents. They created nicknames for sections and passages, informal geography that mapped emotional landscape onto physical space. They told stories about strange sounds in distant passages, about chambers that no one entered, about geological features that acquired significance beyond their physical properties. The strategic validation. The bombing of Coventry on November 14, 1940, demonstrated both the necessity and vindication of underground production strategy. German bombers destroyed or severely damaged 12 aircraft factories in single night, killing hundreds of workers, obliterating months of production capacity. If Britain's aircraft production had remained entirely on surface, concentrated in known factories, German bombing could have crippled British aircraft industry comprehensively. But by November 1940, significant production had already moved underground. Bristol's aircraft engine production had been partially relocated to Corsham. Supermarine components were being made at Spring Quarry. Rover's engine production was transitioning to Drakelow tunnels. When surface factories were bombed, production continued underground, invisible to German reconnaissance, protected by geology that no bomb could penetrate. German intelligence never accurately assessed extent of Britain's underground production. They knew Britain was relocating some manufacturing to protected sites, but they consistently underestimated scope and productivity of underground facilities. Intelligence estimates suggested underground production contributed perhaps 10% of British output. Actual figures by 1942 were closer to 30% for critical items like aircraft engines, even higher for ammunition and specialized components. The underground facilities' contribution wasn't just about quantity, but continuity. Surface factories were periodically shut down by bombing, by need to repair damage, by need to clear unexploded ordnance. Underground facilities operated continuously, regardless of what occurred on surface. This consistency meant production planning could rely on underground capacity in ways surface production couldn't be relied upon during heavy bombing periods. Aircraft production statistics told story clearly. In 1940, Britain produced approximately 15,000 aircraft despite sustained bombing of industrial cities. In 1941, with more production underground, output increased to 20,000 aircraft. By 1942, underground facilities operating at full capacity alongside rebuilt surface factories, Britain produced 23,000 aircraft. The underground facilities had prevented production collapse during critical period when German bombing might otherwise have achieved strategic success. The facilities also provided insurance against scenarios that fortunately didn't materialize. If Germany had invaded Britain, underground factories would have been nearly impossible to locate and destroy. If bombing had intensified beyond even 1940-1941 levels, underground capacity could have been expanded further. The infrastructure provided strategic flexibility and resilience that surface production alone couldn't offer, the human cost and victory. The workers who sustained underground production paid prices that weren't recorded in casualty statistics but were nonetheless real. Respiratory problems from limestone dust affected workers for years after war ended. Joint problems from constant dampness became chronic conditions. Sleep disorders from disrupted circadian rhythms persisted. The psychological impact of months or years spent underground was difficult to quantify, but clearly affected mental health for some workers. 8 workers died in underground facilities during the war, mostly from industrial accidents unrelated to underground environment. This was remarkably low compared to casualties in surface factories that were bombed. The safety from bombing was real and substantial, but the absence of bombing casualties didn't mean underground work was safe, just that it was safer than alternative. Dorothy Mitchell worked at Corsham through 1943 before transferring back to rebuilt Supermarine facility in Southampton. She never fully adjusted to underground work, finding the enclosed space oppressive despite understanding its necessity. Decades later, she described underground period as time she'd survived rather than time she'd lived, necessary sacrifice that she'd made without enthusiasm but without regret. Many underground workers expressed similar sentiments. They'd done what was required, endured conditions that were difficult, contributed to victory, and were glad when they could return to surface. Thomas Garrett remained at Corsham through war's end, becoming supervisor of entire Section C as production expanded. He adapted better than most to underground environment, finding rhythm that made work tolerable, if not pleasant. His section produced over 50,000 aircraft engine cylinders during the war, components that went into Spitfires, Hurricanes, Bow fighters, keeping RAF aircraft flying through years when Britain's survival depended on maintaining air superiority. The recognition workers received was minimal. Underground facilities were classified during war and remained largely unknown publicly afterward. Workers couldn't discuss their service, couldn't explain to friends and family what they'd actually done, couldn't claim credit for contribution that had been strategically significant. Official histories of British war production mentioned underground facilities briefly, if at all. focusing instead on more visible and conventional industrial achievements. The final closure. After war ended, underground facilities faced uncertain futures. Some were abandoned immediately, equipment dismantled and removed, spaces returning to darkness after years of industrial light. Others continued operating through late 1940s, producing civilian goods or military equipment for peacetime forces. A few were maintained as strategic reserves, kept in condition where production could resume if another war erupted. Corsham's limestone quarries transitioned to government storage, housing everything from documents to emergency supplies. The vast chambers that had produced aircraft engines became warehouses for bureaucratic paper and civil defence equipment. Spring Quarry near Swindon was abandoned, equipment removed, entrances sealed, spaces left empty except for limestone dust that had predated human presence and would remain after humans departed. Drakelow tunnels were repurposed as nuclear bunker during Cold War, serving as regional government headquarters that would be activated if nuclear war destroyed surface administration. The tunnels that had produced aircraft engines in one war were prepared for aftermath of different kind of conflict. The irony of spaces built for production being converted to administration wasn't lost on those who remembered earlier purpose. Workers dispersed to peacetime employment, many returning to industries they'd left for war work, others finding new careers in expanding post-war economy. The skills they'd developed operating machinery underground transferred to surface work readily enough. The psychological adjustments required more time. Workers who'd spent years in limestone chambers found themselves disoriented by open sky, by weather variability, by natural light that changed throughout day. The adaptations they'd made to underground existence had to be unmade. Routines that had become automatic had to be consciously altered. Some workers maintained informal connections, periodic gatherings where they could discuss experiences that remained classified officially. These reunions had quality of veterans' meetings, people who'd shared extraordinary circumstances, finding comfort in others who understood what it had been like. The rest of Britain might not know about underground factories, but workers who'd laboured there knew, and that shared knowledge created bonds that persisted decades after facilities closed. The unglamorous necessity Britain's underground factories weren't triumph of engineering or testament to indomitable spirit, though both were present. They were desperate response to military crisis, pragmatic solution to problem that threatened Britain's capacity to defend itself. Workers who laboured underground did so because surface factories were being destroyed, because alternatives were limited, because someone had to produce weapons that Britain needed. The conditions were difficult, often unpleasant, sometimes hazardous in ways different from, but not less serious than surface factory work. Workers endured because they had to, because Britain's survival required aircraft and ammunition and equipment that wouldn't be produced if they didn't show up for shifts that descended into limestone chambers and converted stone to factory floors. What they accomplished was substantial. The underground facilities produced enough aircraft engines, components and equipment to meaningfully affect Britain's war production capacity. They provided continuity when surface bombing threatened to disrupt production completely. They demonstrated that Britain could adapt to circumstances that seemed impossible, could relocate entire industries beneath ground, could maintain production in conditions that pre-war assumptions would have considered impractical. The legacy is mostly invisible. The facilities were largely unknown during the war, remained obscure afterward, left little physical evidence after closure. Walking across fields above Corsham or Spring Quarry, one wouldn't know factories had operated beneath ground unless someone mentioned it. The limestone chambers have returned to darkness, the machinery long removed, the workers dispersed or deceased. But for years, when it mattered most, when Britain stood alone against Germany and invasion seemed possible, production continued beneath British fields in chambers that bombs couldn't reach. Workers descended daily into limestone darkness, operated machinery by artificial light, produced components that sustained RAF aircraft, that prevented invasion, that would have meant Britain's defeat. The underground factories saved nothing directly. They produced components that became parts of aircraft, that fought battles, that prevented invasion. The chain of causation was indirect, diffuse across thousands of workers and hundreds of aircraft and dozens of battles, but the chain was real, and Britain's survival depended on every link holding. The workers who descended into stone chambers, who operated machinery beneath 100 feet of limestone, who endured dampness and darkness and disrupted circadian rhythms, who produced aircraft components year after year without recognition or appreciation, were links in that chain, essential, unglamorous, largely forgotten links that held when they had to hold, that kept Britain's war production functioning when surface alternatives had been bombed into rubble. That was enough. It had to be enough, because it was what they had, and they made it sufficient through determination that wasn't heroic but was effective, through endurance that wasn't celebrated but was real, through work that wasn't glamorous but was necessary. Britain's underground factories weren't monuments to anything except necessity. They were dark spaces made functional, ancient chambers repurposed for modern war, geology providing protection that engineering couldn't replicate. The workers who made them productive weren't heroes, but people doing difficult jobs under challenging conditions because those jobs needed doing, and someone had to do them. When the war ended and production moved back to surface, the underground facilities were closed and mostly forgotten. But for years, when Britain's survival was uncertain and every aircraft component mattered, those dark chambers beneath British fields produced weapons that sustained defense, that prevented defeat. That was their purpose, and they fulfilled it. Not dramatically, not memorably, just successfully. And success, unglamorous and temporary and largely unrecognized, was precisely what Britain needed when alternatives meant failure, and failure meant surrender, and surrender was unthinkable.